In this video, we're going to talk about the normal curve a little bit more and talk about those percentages and the area under the curve. And we're going to talk about how to find the percent of scores above or below a particular z-score, and also how to find a z-score from a percent. So as we're looking at the normal curve, and as we saw a little bit of in our earlier video on z-scores and the normal distribution, we have this mean of 0, and the way this is divided, because our normal curve is symmetrical and unimodal, we have 50% of the scores that are above the mean and 50% of the scores that are below the mean. And if we break this down further, we can see that in each of these spaces between these standard deviations, between our z-scores, there's a particular number that's the percent of scores in that portion of the curve. And if you add these up for either side, from 0 to the end or from 0 to the other end, we'll get 50. So there's 50% in each half. But we also can see that there's 34% of the scores between 0 and +1, for instance, or 0 and -1. 14% of the scores from +1 to +2, and -1 to -2. And 2% of the scores from 2 to the end, or -2 to the end. And so we can use these percentages to figure out what percent of scores rather is above or below any particular score. And so, for instance, if I was going to say how many scores are above 0, I could know that that's 50% or add these up. If I wanted to say what percent of scores rather is above the standard deviation or a z-score 1, I could add these up and say about 16%. But I can also find much more fine-tuned information by using what's called the z-table. This is typically in your statistics textbook. In our textbook, it's in the back of the book. And so you'll be using this extensively as we talk about z-scores, and also when we talk about hypothesis testing and talk about the z-score later on. And so we're going to use these percentages. It's helpful to kind of start to try to memorize these percents because we'll be using them pretty extensively. And I always encourage, again, draw these out as you're working with these different kinds of percents and figuring out percents to z-scores to percents. This can be very helpful to kind of have this on paper right in front of you. So as a little bit of an introduction to the z-table, usually this looks something like this. And so we have a couple of different pieces of information here. And so first, we have two different halves here, but 3 columns in each part here. And these are the 3 columns we'll be looking at throughout. The z-table is just fairly long. And so we have kind of a continuation on that second half. And so the first thing that we see here is our z-score. So we have these different z-scores that are represented here, going up in these increments. Next, in our second column here, we see the percent mean to z. And this little diagram up here shows what that's showing. So this is the percent that falls between the mean and whatever z-score. The mean to z-scores and really all the z-scores here in this table, these are all positive, but the same goes because it's symmetrical. We only need one version of the numbers, and that goes for positive and negative. So between the mean and a z-score of 0.11, for instance, really, really close to the mean, there's 4.38% of the scores. And similarly, for negative 0.11, it would also be 4.38% of the scores. And so that's the mean to z. So we're going from the middle out to that z-score in whichever direction we're going. For the percentile, we're doing something different. For the percentile, we're saying we're going from the z-score and to the tail. And so, for instance, from a z-score of 0.11, so again, really close to the mean over here. If we go from that 0.11 out to the tail, there's actually going to be 45.62% of the scores in that section. And again, same thing on the other side. If we had negative 0.11 rather, we can go out to the left here, and there'd be 45.62% of the scores in that tail as well. And so this is how we'll be using the z-table, and we'll be seeing that there's a couple of different ways to use it, but in this particular video, we're going to be focusing on figuring out what percent of scores is in it corresponds to a particular z-score. So if I want to find the percent of scores above a z-score or below a z-score. And also later in the video, we'll talk about how to find a z-score if I'm given the percent. And so to find the percent of scores above or below a raw score or a z-score on the normal curve table, or the z-table as we're calling it, there's a couple of different steps. And so with everything that we do, we're going to have these step-by-step processes. And so to find this percent, what we're going to do is we're going to use our z-score. You may have already been given a z-score. You may have been given a raw score. If we have a raw score, we're going to just automatically change it to a z-score. And in order to do that, we're going to go back to our instructions for how to change a raw score to a z-score. So if you're not familiar with that, then you can check out my earlier video on that. And if you are familiar with that, you can go ahead and change any raw scores that you have to z-scores, and you'll be all set. But you want to start out this process with your z-scores. The second thing that you're going to do is you're going to draw a normal curve. I know that sometimes this makes people a little uncomfortable. We don't always like to draw unless you feel like you are very good at drawing. I am not very good at drawing. You guys have seen my handwriting perhaps in some of my example videos, but we're going to draw a normal curve. This is just a little sketch. It's just for yourself, really, although you might turn this in if you're turning in work. And what you're going to do here is you're going to draw this out. And again, this is so you have a visualization. And this step is so important because it's going to actually really keep you from making some mistakes. So it may be tempting to skip step 2. Don't skip step 2. So you're going to draw a normal curve. You're going to decide where that z-score falls on your normal curve. And you're going to shade in the area for the section for which you're finding the percent. So for instance, I'm going to find my z-score. And if I'm finding the percent of scores above that z-score, I'm going to shade in everything that it looks like it's above that z-score. If I'm finding the portion below, I'm going to shade in the part that's below that z-score. And I'll show you an example of this. Step 3 is we're going to make a rough estimate based on the shaded area's percents, and based on that 50, 34, 14 percentages that we know. And so we know those percentages. We can go back to that earlier slide, or if we have those memorized, we know about how much of the percent of scores should be in each one of those sections. And so based on the shaded area, I can draw in those other lines for 1 standard deviation, 2 standard deviations, etc. And I can make an estimate of how much of that I think it is. And I'll show you there's basically 2 ways that I like to make an estimate. And so you can use whichever you're comfortable with, whichever works for you. But I'll show you 2 different ways that I like to do that. Step 4, we're going to find the exact percentage using the normal curve table. To do that, we're going to look up the z-score in the z column, and then we're going to find the percent. What we have to be able to tell is we have to figure out for ourselves whether we need to use the mean to z column or the percent and tail column. And that's going to depend on the situation. And I'll show you 2 different examples of this so that you can see this in action. This is a really important part here. And this kind of goes along with step 4. So if the z-score is negative and we need to find the percent above it, or if it's positive and we need to find the percent below, we need to actually add 50%. Those are the situations when we're going to be using the mean to z column. And in those cases, we usually need to remember that we're really only getting that part of the curve, and we have to account for the other half of the curve that's not being accounted for by that mean to z column. And so this is also really where your estimate is going to come in such handy, because what you're going to do is you're going to find this exact percent. You're going to have to remember to check whether or not you need to add 50%. And then in step 5, you're going to check that the percent that you calculated in step 4 is near to your rough estimate. If you find that the percent that you calculated in step 4 is about 50% off, you probably forgot to add your 50%. And so checking your estimate, you making that estimate, you drawing it out, making the estimate, and then checking that estimate is really going to save you from a lot of potential errors. So let's take a look at this. And so if I wanted to find the percent of scores that is above a z-score of positive 1.64, let's try this out. And so in order to do this, first step is I need to make sure that I have a z-score. And if not, I have to change it to a z-score. It says I have a z-score here, so I've already got this. Next, what I'm going to do is I'm going to draw my normal curve, shade this in, finding this z-score. And so I'm going to make a note to myself here that I am using a z-score of 1.64, and we're looking above that 1.64. And so I have here already actually a little sheet that I've made up, and I suggest you can draw this out for yourself on paper or a tablet or whatever that you're using to practice this. And feel free to practice right along with me. You can always feel free to pause these videos when we do some practice if you want to try it on out for yourself first, and then continue playing to check your answer. And so you can see I've drawn this normal curve here, and I've put in some of these lines here. So I could put in some numbers here as well. That would be helpful. But right here in the middle, we know that this is going to be 0. 1 standard deviation is these first lines away from the middle. Second lines is going to be 2 standard deviations, or a z-score of 2. And so I have this already drawn in. Keep in mind, this does not need to be perfect. I don't know really when I'm just kind of estimating where these lines should go. As long as I know that this is supposed to be my first standard deviation, my z-score of 1, and so there should be 34% of the scores in here. It doesn't matter if this drawing is super accurate. This is a sketch just so I can visualize this, and it's really all that's about. And so I'm going to do a couple of things here. And so the first thing that I'm going to do is I'm going to actually just select to make a line here. And so I'm going to shade in. Again, we're looking for the portion above 1.64. And so if this is 1 and this is 2, I'm going to say 1.64 is going to be just around here, somewhere between 1 and 2, maybe a little bit closer to 2. But if it's between 1 and 2, I know that I'm probably going to be pretty close. And so now what I want to do is I want to shade in the portion above that. And again, I don't have to be really precise here. That's just for myself. I can shade this in however I want to shade this in, but I'll just kind of scribble in here so that I know that this is the section that I am going to be finding my percentage for. Now I need to make my estimate. So I mentioned to you guys that there's 2 different ways that I like to make an estimate. And so the first way is to kind of just give a range. And the second way is to give a more precise estimate, just a single number estimate. And so for instance, if I want to know what the percent is up here, well, I know that from the z-score of 2 on, there should be about 2%. And I know between 1 and 2, there should be about 14%. So if I'm looking here, I could say, well, this is going to be between 2 and 16% if I add that together. So I could say this is 2% to 16%. Or I could make a more precise estimate. And so if this is going to be about 14% in here, this is about halfway through. So I can say maybe this is going to be about 7%. It's going to be a little less because this side is shorter than that side. But 7 is a fine estimate here, and plus 2%, so I can make this estimate as being about 9%. And again, these are rough numbers, but you can do either kind of estimate for our purposes, and that's how I like to do this. So now what I have to do is I need to find my value on the z-table. And so I'm going to look this up in the textbook here. I need to figure out if I need to get mean to z or percent in tail. And I can tell here, we're not anywhere near, if I was over here, then, but if I'm getting above a positive score, I can see this is the tail. The tails are when we're going out towards the end. We're going out towards the end here if we're looking above this positive number. And so I'm going to use my percentile column and look up a z-score of 1.64 and take a look at what the number that corresponds to 1.64 is in my percentile. And what I would find is that I have 5.05%. So now I get to my last step. And again, don't forget to do that last step. Our last step is to check, is my estimate correct? Is my estimate nearby the answer that I got in step 4? And here, 5% is close to 9%. Relatively speaking, that is pretty close. I am between my range, so 2 to 16%. 5% is in between there. And so I can feel pretty confident that this answer looks right. And again, this estimate and checking everything, this is really to help us, the shading in the estimate, the checking. This is to make sure that we're using the right column in the z-table, and this is to make sure that we're not missing adding in that 50%. And I'll show you in this next example, another example of what that looks like. So let me go ahead and clear out some of my scribble here, and we'll do another example. So what about if we do a question where we're looking for the percent? We're still looking above. We want the percent above, but this time we're going to use a z-score of -0.5. So let's try this again. Same thing here. We're going to first make sure we have a z-score, which we do. We said our z-score was -0.5. We can double check this right here. We have a z-score. And so the next thing that we're going to do is we're going to find that and we're going to shade it in. And so again, I'm going to put a line in here and -0.5. So we want basically just between our mean of 0 and -1. And again, it would be helpful if I put some numbers in here. I suggest that you do, but I can tell that this is the mean because it's right in the middle and -1. So that's going to be around where my -5 is. And again, now I want to fill in and shade in this whole section that's, wait, we said above. Let me make sure I'm reading the instructions here very well. So we're going to scribble in this whole section above. And again, this doesn't have to be pretty, but it's going to give me an idea and it's going to make sure I'm focusing on the right things. Eek, well, that didn't work. Let me try. I will put in a couple of rectangles in here instead. Again, we're just doing what we need to do here to try to shade this in a way that you guys can see this. I'm going to shade in as much as I can here, and we're getting the idea. All right, so I've shaded in. I need to make my estimate. And so I know that this whole half from the mean on, from this middle point on, is going to be 50%. So I know that it has to be more than 50%. So again, if I'm doing a range, start with 50. And over here, I know this part between the mean and -1 is going to be 34%. But we're halfway there. And again, because of the difference in height here, it's going to make a difference. It's not going to be exactly half of 34%. But I can get the I can use that half of 34% and say 17. So 57 to 50 plus 17 to 67%. And again, if I want to make a more precise estimate, that's fine too. I can, actually, I kind of did that with my 67% actually. So I could say 67%, or I can say 50 to 84% if I wanted to do a range. So we have our estimate. We have to look in our z-table to get our answer. And again, in this case, what we have to do is figure out, do I need to look in my percentile or mean to z? Well, we know that the z-table is only giving us half of our normal curve. So what we have to do here is look at the mean to z, because here we have the z-score over here. We know that there's 50% over here, and we need to get from the mean to the z-score. And so I want to look up my z-score of 0.5, and I'm going to look in that mean to z column. And so if I go to 0.5, mean to z column, I get 19.15. But I can't stop here. If I stopped here and I said my answer is 19.15, and I go on to step 5 to check my estimate, I'm going to find that 19.15 is nowhere near 67%, and it's not between 50 and 84. And I can probably assume that I've done something wrong and I've forgotten to add my 50%. Hopefully, though, I will remember that I do need to add that 50%, and I will come out with an answer of 69.15. And then that would be very nice and close to my 67% between my estimate of 50 and 84%. And so I'm in good shape here. And again, this is where making sure that estimate, checking your answer against that estimate is going to save you in the long run. And so let me clear out this. And we're going to move on to talking about how to find a z-score when you're given a percent. So how do we do this? And again, we can find a z-score or a raw score from a percent on the normal curve table. We're going to draw our normal curve. We're going to shade in the approximate area for the percent. We're going to make a rough estimate of the shaded area z-score. So we're going to turn things around a little bit, but our procedure is very similar. We're going to find the exact z-score using the normal curve table, subtracting 50% now if in the problem if necessary. And we're going to check that our exact z-score is near our rough estimate. And lastly, this is going to get us our z-score here. If we want to find a raw score, we're going to go back to our earlier formula for how to change a z-score to a raw score. So a little bit of practice here. What z-score corresponds, we're finding a z-score that corresponds to the top 75%. And so if we are finding a z-score that corresponds to the top 75%, first thing we're going to do is we're going to draw and shade in our normal curve. And so the top 75% means I'm going from the top end and I'm going to the left. I'm going to shade 75% of that top portion. So I know this is 50 and I know this is 34, so I don't need all of this. So maybe around here-ish, a little further over than half, and because we want 50 and 25 basically. And I know there's 34 between these two lines. So now let me shade that in. And just in case that scribble doesn't work again, I'm going to just use my boxes. And again, this isn't exact, but it gives me enough of an idea of the portion that I'm shading. One more in here. All right. So I've drawn and shaded in the area. I'm going to make my estimate. So here, my estimate, I'm going to estimate what my z-score is going to be because I know what my percent is. And so, well, I know that my z-score here is 0 and my z-score here is -1. So I can easily say that my estimate is going to be between 0 and -1. Or if I wanted to be more precise, I could guess that it's, well, I know it's going to be a little further over than 0.5, maybe, so I could say maybe -0.6 or something like that. Now I'm going to find that z-score on the table. And so in this case, I'm going to be using my mean to z again, because I have my z-score here. I need to find the amount to the mean, not in the curve. And this time what I'm going to be looking up is that my mean to z, and then check what the z-score is that corresponds to that. And so in order to do this, I need to subtract 50. And so what I'm going to be looking at is I'm going to try to find the mean score, the mean to z score that's for 25%. So looking in my z-table here. So 25%, we're going to get as close as we can since it's not, there's no exact 25% here, but there's the closest one here. Let me take a look. We have 25.14, so that's pretty close. And that gives me a, oops, I'm actually looking in the wrong column. Let me try that again. We have, yes, 25.17, and that gives me a z-score of 0.68. And again, I encourage you guys always double check that you're checking in the right column, mean to z or percent of tail, because that little double check will help. I make these mistakes too, and so I have learned to double check this. I encourage you to do the same. I'm going to remember that it's negative because I'm on that negative side. I'm going back to my drawing here. And then my next step is to check it with my estimate. And so I have negative 0.68. That is between 0 and -1. It's close to that -0.6. Again, you only have to make one of these estimates, but both will also help you if you wanted to do it that way. And we're only looking for a z-score. This is going to be z equals negative 0.68. And if I wanted a raw score, I could change it to my raw score, but I only need a z-score here, and so I am all set. Hopefully this taught you a little bit about the normal curve and got you a little bit of practice with working with these kinds of percent problems. And thank you for watching.